We will start in our vocab area. So, exponent. What's an exponent? Tells you how many times to multiply the base times itself. Tells you how many times to multiply the base times itself. As the books say, an exponent tells you how many times a number called the base is used as a factor. So that's how the book says it. So I'm going to write out 5 to the third power, like that. So the exponent, that is the tiny little number right over there. That's your exponent.
Can we still be in our definition?
Yes, I'll let you know when to switch to notes. We'll be here for a bit. And you can see exponents all over your sheet here, but these little numbers up on the upper right, like in superscript, those are the exponents. So that's the exponent. This is the number that we call the base, the number that we're multiplying over and over and over. So whatever the base is, in this case 5, and the exponent 3, what it's telling me is this is telling me how many times I multiply this number times itself. So how many times am I multiplying 5 times itself?
3.
Or 1, 2, 3 times. So then to solve it, you just go ahead, 5 times 5. 5 times 5 is 25, but I'm not done yet because I'm multiplying it times 5 3 times. 5 times 5 is 25, but then one more time times 5 should get an answer of 125. That's 5 to the third power, 125. Okay. And we'll go both ways. We'll practice these a little bit, but I mean, for number 1 here, you can see what they did. They're referencing 6 times 6. How many times? 1, 2, 3, 4, 5. So we're multiplying 6. That's its base. How many times are we multiplying it times itself? 5. Okay. So we'll practice that in a little bit. The laws of exponents. And we're going to get into what's going on back here about how this stuff works here. Multiplying and dividing with exponents here. So you're going to see this off and on. So multiplying. All right. Laws of exponents. So there are 3 of them pretty much out there. And one of them we have covered before. And it's the 0 power one. Anything to the 0 power equals 1. With words, 0 power equals 1. Always. Except for 0. 0 to the 0 power. What is 0 to the 0 power? 0, 1x, 0, error. 6, 1x, 0. But anything else is 1. Okay? Anything else is 1. Doesn't matter what I put there, except for 0. Not possible. So for all practical purposes, anything to the 0 power equals 1. Anything. Anything. All right, there's law 1. 2. Law for multiplying exponents. So this law only works if the bases are the same. all these last laws here. So when we get to this over here, notice how the bases are always going to be the same. That matters. So it doesn't matter what the base is, but base must be same number for this law to work, otherwise the law doesn't work. So whatever the base is, I'm just going to call it A. Okay? So A to whatever power it may be times the same thing, A to whatever power that is, equals whatever the base is, and we add the exponents. This is going to be the whole key here. So, brief example here. Again, the base has to be the same number. If I had 6 to the third power times 6 to the, fine. How about the fourth power? There you go. Trust me on this one here. Trust me on this one. So what I am telling you to do here is, in this case, what does A equal?
6.
Because it go back up here, A is 6. What is M?
3.
M is 3. What is N?
N is 4.
And it's 4. Because A is whatever the base is. It's always got to be the same. M and N are the two exponents. So what I'm saying here is I add these together. I got 6 to the 3. What's 3 plus 4?
7.
This equals 6 to the 7th power. Right? And we could certainly solve that. We won't do it right now. Multiplying 6 times itself 7 times, but whatever 6 to the third power is, that's 216 times 6 to the fourth power, 36 times 6. Seen that one before? Times 6 to the fourth equals 6 to the 3 to the 4, plus 4. So for division, last thing here for our notes, and then we'll practice this a bit. Law for dividing exponents. And same general thing, base must be same number. So when we were multiplying, what did we do with the two exponents?
You just kept them. Oh, you just added them.
Added them. So when we're dividing, what do you think we're going to do with the
Divide
two
them.
exponents?
Divide them. Add them.
Somebody else.
Subtract them.
Exactly. We're going to do the exact opposite. So if I have same letters, a to the m power, this time divided by a to the n power, when I get to the exponent, it's going to be a to the m minus n. We'll
What
do
if
the exact
n
opposite.
value is bigger than the n value?
Then we would have a negative exponent. Right. So I don't think, or at least not right now, you guys don't have that issue. That comes, I believe, later on this year. 8th graders get that. You'll see negative exponents eventually, just not yet. But they're coming. So difference, of course, this time was we subtract. That's the whole difference between these two. When we're multiplying, we use addition. And if I did the similar example, I'll say 6 to the 5th power divided by 6 to the 2nd power. So it would be 6 to the 5 minus 2 power, and 5 minus 2 is 6 to the 3rd. This, again, these laws only work when the bases are the same number. So they will be the same number here, not throwing your curveballs at it. Subtraction can be referenced in fraction form or with the division. I think we talked about it many times over, but this is the form that you're going to be seeing more often, this less often going forward. But this and this, they are both division, they are all division problems here. Multiplies, not a ton of them here, but guaranteed you'll see these on your quiz and tests. So I might make a few up here for us to practice. Okay. Any other issues or questions with what we're doing today here?
Nope.
Before we shift to notes?
Nope.
Okay. Well, shift over to notes here. Fill your notes page 19 once again.
I always do that. I'm smart.
Okay. Workbook, page 17 and 18. Yes?
Yep.
Okay. So looking at number 3 here, it says write an exponential form. And I got that right there. So all we're really doing here, writing an exponential form, how many times am I multiplying 7 times itself? 3. So I could say that is 7 to the third. I'm going to just, well, I'm going to go like that. It's fine. And then how many times am I multiplying 5 times itself? 4. And at the moment, they don't want us to solve it, which is nice. But whatever, 7 times 7 times, simpler way to write it here. Okay. Try number 5.
Okay. I'm gonna get it one. I'm really bad at doing exponents because I usually make them the exact same size as the numbers.
Do you want us to write like all the problems or?
Um,
Really bad.
I would in your notes here, so you have examples. You're gonna have some. Let's save it for the next part. So. Yeah. Jackson, what do you think for this one here?
I thought maybe -7 to the 4th.
So,
I'm not sure.
like that?
Yeah.
Mm-hmm. Anybody else?
No. That's what I got.
That's not what I got, but what I got looks good.
So, what this essentially is saying to me here is this is the opposite of 7 to the 4th power. And the opposite of anything is just flip the sign. So 7 to the 4th power, if I include the opposite of that, basically this is sitting outside the brackets. It just comes with me here. This would be good. If I put brackets, depending on where you go, if you put brackets around here, that's fine. The one thing that wouldn't work, though, would be this. That's different. So I have this, that's okay with the brackets here. I have this, that's okay. But that one, not so much. Why is that one different? What's wrong with, what's different about this one from these other two?
Everything is out of the bracket.
So what is this telling me?
It's
That is
negative
part of the problem. That's part of 7.
So
would I write this out? If I wrote it out, this is expanded form. If I wrote this in expanded form, what would it look like?
-7 times 4 times 4.
4 is the exponent. It's telling me how many times to multiply -7 times itself. So what would it look like?
Oh, it would be.
What am I multiplying over and over? What number?
-7.
So how would I write that?
-7 times -7 times.
Right, in this case here, I notice how every single one of these, every single one, I could do it that way too. -7 times -7 times -7 times -7. This is -7 to the fourth power. This are all positive sevens here. This is just telling me it's the opposite of. So this isn't like a -7 to the fourth, because it's the opposite of 7 to the fourth power. We'll represent it with a negative value here, but again, keeping it so it's not inside the box. The only way I could reference -7 to the fourth power is this way. I would have to have these brackets here. If I didn't have these brackets, I'm representing the opposite of 7 to the fourth power. And again, you're going to see this scenario play itself out time and again throughout this lesson here, but how you represent each of these things matters, because these are the same and this is different. So keeping track of, how this is going to work here, and can be part of the battle. But this is -7 to the fourth power. This is the opposite. Both of these, same thing. The opposite of 7 to the fourth power. They are not the same thing. They are not the same thing. They are not the same thing. This one here will give you a negative outcome in the end. This one, even number of negatives, will give you a positive answer in the end. Right? Positive outcome, because for even number of negatives, positive outcome, right? But this is outside. It's just one negative, odd number that just comes with us. This would be a negative outcome here. Negative answer. Positive answer, negative answer. Right, a little getting used to here. So number 7. And again, I challenge you, you got to be very careful how you write this problem here. But write this in exponential form. Right here. Number 7.
See, 4 people just talked. That's an excuse.
Yeah, stop. It's a truth.
Stop. No, stop. Stop.
So to write this out here, you need to have brackets around -5 and -4. If you don't have brackets, the -5, because it's to an exponent, has to have it. I mean, if both numbers aren't in brackets, you're going to lose at least half a point. Guaranteed. Guaranteed. Because if I write it this way,
Yep, that's how I did it.
you are representing to me the opposite of 5 to the third power. You are representing this to me, -1 times 5 times 5 times 5. If you write it that way, that's what you're showing me here. But that's not what this is. This isn't -1 times +5 3 times. It's -5 times itself 3 times. So if you wrote it this way, this is what you've shown me here. But that's not what's going on. So if I don't keep it in the brackets there, because that is showing me negative, this is the only thing that's showing me -5. This, oh, if you got the bracket, but it's sitting outside the bracket, again, this is and this are identical. You're showing me the opposite of 5 to the third power. That's not the scenario at all. So, and same thing over here. If you put times, you should put it in brackets. I guess since it's not to an exponent, I could kind of live with it. But again, you would run into this order of operation confusion, especially if you didn't put it up real high. If you put it down here, if this is what you wrote, my question would be, what exactly is that? Right there, looks like times minus.
That's what the book does sometimes.
Not so much this year here. I mean, looking through this here, they're very clear and specific here. There's no issues with this lesson in the book and how they're utilizing the brackets,
The
so.
brackets would be around the
But
negative.
you need to get those brackets around there to prevent this type of problem, especially if it's to an exponent. Otherwise, again, you're representing the opposite of a situation. So this is it. If you represented it this way, that's wrong. You've represented this situation to me here. So when there are negative numbers, they always have to be in brackets. Always. Always, always, always. If it's not in brackets, then it's the opposite of a situation. The opposite of a thing and a negative number are not the same thing. And for a while, it's easy to see how because what we did up to this point, they kind of functioned similarly. But now, as we're starting to divide deeper into exponents, we need to kind of separate this a little further here. Negative exponent or negative numbers, opposites, they're not exactly the same thing anymore because of this situation right here. Try number 9.
Number 9, that's my hockey number.
That's my number minus another.
Your number's 21.
My number is not
Mr. Mertz looking at you. Hey, why are you looking, Jack?
I do.
No, Jack.
Oh, I can't.
Because he said not to mind you.
I mind.
Okay, well, you don't have a mind.
Oh.
All right. So, what do I need here? Dominant. What do I got?
So, you count up all the 21s.
Mm-hmm.
You got 5 of them, right?
Yep.
Then you got negative 21 to the 5th power. You put parentheses around negative 21.
Do I need the parentheses this time?
No, because it's not. I mean, yeah.
Yeah, definitely. This is a negative 21. Anything else, if it's not in the brackets, you are representing the opposite of positive 21 to me. In this case, if you worked it out, you'd get the same answer one way or another, but that's because, again, the opposite is 1 negative. In this case, you're lucky. You had 5 negatives, so you would get the same answer either way. But that would be more of a lucky situation than you did it right type of deal here. So, but to represent it, yeah, we must have the brackets because it's that negative value.
Put the brackets at the
Right. Okay. All right. Next part here. It says write each in factored form. This is factored form right here. So we're going to write it out the other way, same way we just did it. Number 11. Then evaluate. That means solve it. So we'll do 11. 3 to the 4th.
Can we do 4 to the 3rd? And like, right, so I don't take up as much room. I won't do that.
3 to the 4th and 4 to the 3rd. I didn't know there's that much room difference.
I mean, you never know.
You'll get a double-digit answer here, so you probably could do it all in your head.
I got it.
Yeah, that's what, yeah.
No,
But
you're not getting it.
so writing in factored form first. So 3 to the 4th power, if I write it out, I call it kind of expanded form, I guess, but so that's what I'd be looking for there for half of it. 3 times 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So in factored form, then solve. Try number 13.
No. Oh, it's only 7 to the 3rd.
So write it out in factored form.
I don't. 49.
Oh, yeah.
Yeah. Oh. Okay, they didn't use parentheses.
Oh my gosh.
No, they did not. And that matters, doesn't it?
That's really bad.
If there's no parentheses, that matters.
Yeah. Wait, can you show that example? Like that person.
It's very bad. Wait.
I somehow picked the exact situation there. Oh, that's no fun. The example is exactly what it is.
Oh, yeah.
What are the odds? I didn't want that. Terrible. The example I showed you earlier is exactly what this is here. It's horrible. So, regardless, I would think whether you did it right or wrong, you should come up with negative 125 is the answer. I'd be surprised if you got a positive one, because either it's, so the question is either there's 3 negatives in this thing or 1 negative in this thing. How many negatives are in this thing? 1 or 3?
3. 1.
This is, it turned out the exact same thing I was illustrating to you right over here. I mean, literally, I didn't realize it till Brooke just pointed out, but when I broke this down for you, what did I show you you were representing to me? I showed you were representing the opposite, and the opposite is always times negative 1. If I say the opposite of negative 2, and you multiply that times negative 1, well, then you get a positive 2. So whenever I say the opposite, it's always times negative 1. And this is the opposite of 5 to the third power. So if I covered it up here, just covered up the negative symbol, right, and just had 5 to the third power, kind of like 3 to the fourth, I don't think you had any problems up here, right? Right? Remember when we did 3 to the fourth up here?
Yeah.
But what if I did this? What if I said it's just the opposite of 3 to the fourth? What's the opposite of positive 81?
Negative 81.
So all I really did was just multiply by a negative 1.
So it would be wrong for 13 if we did like negative 5 in parentheses times negative 5 in parentheses times negative 5.
Right, because that is what you just showed me there. That's this situation right here. This is negative 5 times negative 5 times negative 5. That's negative 5 to the third power. This is the opposite. So whenever I see the opposite times negative 1, we're flipping the sign. 5 to the third is positive 125. The opposite of 125 is negative 125. It is the opposite. And to get the opposite of anything, I mean, if I had this, how would that go?
No, it'd be positive.
I just multiply negative 1 times negative 5 times negative 5 times negative 5. Now I would have a positive 125. The opposite of negative 5 to the third power. Negative 5 to the third power is negative 125. Negative 125 times negative 1, positive 125. So whenever we have that negative outside the box, it means the opposite. It means multiply by negative 1. You need to show me multiply by negative 1 then. Is it a negative number or is it an opposite? Okay, try number 15.
The answer was
So for 13, yep, 13, it's negative 125, and this is the setup I need. I need to see times negative 1 somewhere in there. If you don't have times negative 1 in here, you're not showing me the situation. You never referenced your opposite situation here when you wrote it out. So this is the answer for 13 right here. If you did the negative 1 later on, cool. I mean, that's fine. If you wrote it this way and multiplied by negative at the end, that's fine. Doesn't matter if you do it first or second. Usually you do it first, though, because it's before the problem. I mean, it's the opposite of negative 1 times what? So it's usually done at the front, but I wouldn't hold it against you.
I'm just gonna do it anyway because
So, how's this one gonna look?
Okay, let's see. Ooh. Oh. Oh. Oh, that's the one that, oh.
And again, there's really two ways this could go. It could be this, or I'm sorry, it could be the opposite of 4 to the 4th power, or it could be this. But it sure ain't both of them. So, one of them is this, and the other one is that. Or I could even put the brackets here if I want. So, one of them is this, that's the correct answer. One of them is that is the wrong answer. So, which one is it? Number 1 or number 2? Which is 15? Number 1 or number 2? Take the class poll. The class poll. Sig, number 1 or number 2? Which is the correct answer? Which of them is this? Number 1 or number 2? Sig. 1. Jackson. 2. Sarah. 2. Savannah. 2. Dom. 1. Damien.
Oh, no, number 2.
2.
I got confused.
Brooke.
Number
2.
No.
I think some of you are backtracking your way. Number 2, guys, you are correct. That is what's going on here. This is negative 4 times itself 4 times. Negative 4, negative 4, negative 4, negative 4.
I thought you meant below it.
This is the opposite of 4 to the 4th power. So 4 times 4 times 4, the opposite of times negative 1. So this is that, or this. Both of these are number 1. But this is the way it has to be. And it has to be. Do you see why these brackets have all this significance all of a sudden here today? I mean, I realize it's kind of a lot to absorb here on you here. I get it. So it's kind of weird. But how we say it, if you can say the scenario with words that infinitely can help you understand it, if you can verbalize what the problem is. Because if you can verbalize the opposite of or, right.
if the negative symbol is outside of the brackets, then it is written not like number 1.
If it's outside of the brackets, it is representing the opposite of what? 4 to the 4th power, right. If it's outside of the brackets, or there are no brackets at all.
It's real like number 1.
Right.
Okay.
Yep. And then in that situation, again, that negative sitting right here is where this times negative 1 comes from. Once that's there, they are one and the same thing. We've dealt with it. Now what's left? 4 times 4 times 4 times 4. Okay. So what was the answer to this in the end anyway? Anybody?
Negative 256.
Positive 256. Even number of negatives. 1, 2, 3, 4. 4 negatives. Even number. Positive outcome. 256. And I got there. 4 times 4 is 16. 16 times 4 is 64. And then 64 times
I wrote it like
4
number 1.
is 256. So positive 256, even number of negatives. Negative 4 times itself 4 times. Even number of negatives. Okay. Let's try number, you don't have a lot of these either, so we'll look at 19. PEMDAS rules come into play. I might make up 1 or 2. Again, you'll see this scenario again. 7 squared plus 7. So, I believe electronic me tomorrow will do the PEMDAS lesson with you tomorrow. That is a chunky lesson.
Like good or bad?
Well, you can flip the page and look at it yourself.
It looks kind of normal. It looks normal.
The backside is a little more 20 through 30. There's
Oh my
things
God.
there. Right. So using all your newfound knowledge of exponents and negatives and all this fun stuff, you can combine all those things together there. into one mega lesson tomorrow. So it's one of those love-hate lessons. At the minimum, I hope you enjoy it more than the properties lesson. At the minimum. Okay, 19. Anybody think they have an answer here? Brooke?
56.
56, Dom? Yeah. So PEMDAS rules apply. You always clear out exponents before adding or subtracting. So the first thing I do is figure out what 7 squared is. 7 times 7 is 49. And then I add 7 to that. So you always clear your exponents before you do adding or subtraction. PEMDAS. 49 plus 7, answer is 56. I'll just make up a couple here real quick. 4 to the third minus 2 to the third. And 5 to the second plus 3 to the third. Try that. Minus 2. Okay. So 4 cubed minus 2 cubed, 5 squared plus 3 cubed minus 2.
Literally the same.
Not allowed to say that ever again. Wait, and then 5 to the second plus 3 to the third minus 2. That 2 just came in that.
Wait, which one are we supposed to do?
These two.
I know.
All right. Pull 2 sticks here in a moment. Looks like most of you are working.
I'm not ready.
That's fine, Sam.
My goodness.
All right. So the first one here. What are you seeing? What are you thinking? Brooke?
The first one.
Yep.
So I changed the 4 to the power of 3 to 64, and then minus 8, and that equals 56.
Right. If I wrote it all the way out here for what it's worth, I'd have 4 times 4 times 4 in brackets, subtracting 2 times 2 times 2.
Is that what we need to write on the test?
You'd have to just solve. You have to put it in an expanded form like this. I'm just illustrating to you what we just did here, just showing it to you. What I care about is 56. If you get 56, I love how you did it, Brooke. But this is what's going on here. Basically, I do one multiply problem, get my 64, then I go over here, do my other multiply problem, subtract the 2 products from each other, and there we go. All right. Sig, other one.
Okay. 5 to the second power equals 10.
5,
Wait.
that's 5 times 2.
Never mind. No, never mind. 25. 25 equals 25.
So-
equals
so-
25. Okay.
Right.
18 minus 4.
Okay. 3 times 3 equals 9. And then 3 times 9 equals 27.
Yep.
Hey. Yeah. Then minus that equals calculating. Wait.
It's okay, you'll get it.
Oh, I'll get it. Eventually. Might be a little bit later. Wait, no, not that. Wait. Okay. It's 50.
Yes. Thank you.
Four.
So you can add or subtract in any order you want, but I would be looking for 50 there. Okay, good with that. 2 more parts. We're getting there. Backside. Multiplying or dividing. So number 23. And you are being challenged to write this out It's all the way. So in a sense, write this all out in the expanded form first. Very similar to what you were doing over here. You need to write it out that way and then solve. The only difference this time is now you have two numbers instead of just one. On this page, you only had one number, but now, same deal. So, how do I say that? How do I write that? Think it through. It's very specific in how you need to write it. Very specific. Give you a moment to ponder it out there. I'll write it out, but see what you can do with it. Anybody think they can say that problem with words?
Yeah. Yes. -5 to the second power.
No.
-5.
No.
Wait, the opposite of 5 squared. No, yeah, squared.
Yeah, the opposite of 5 squared times
-3 cubed.
-2 cubed.
I don't. Yeah.
That's it. The opposite. So what does that tell you when you write it out? Whenever I say opposite, what do you need to do? The opposite of 5 squared times -2 cubed. So the opposite of 5 squared. So when I say the opposite, that means multiply by -1. The opposite of what? 5 squared. That's 5 times 5. Times -2 cubed.
Let's go. I got it. Oh my god.
So that's how this one would look here. The opposite, it's times -1 of 5 squared, that's 5 times 5, times -2, 1, 2, 3, 3 times. There should be 6 numbers here that you're multiplying. So ultimately 25, 2 times 2 is 4, times 2 is 8, 25 times 8 is 200, positive or negative?
Positive.
Why?
Because there's two negatives.
Yeah.
There's 4 negatives.
Oh, yeah.
1, 2, 3, 4. 4 negatives. 1, 2, 3, 4. Positive 200 is what you should get. 4 negatives.
And I wrote it right, too.
In the end, there's 4 negatives and 2 positives in this problem here. Because the 5 squared is positive. It's the opposite. -1. Okay. Try 25.
That's not half the number, the right number.
It's actually not.
I mean, yeah, it is. What left? It's also my birthday.
See, nobody gives a crap.
There's shortcuts in this problem, by the way.
Oh,
Depending, there's a couple opportunities.
Yeah, but
You know, you
like-
can work this out however you want. But
27 divided by 3 is 9, but like. What do you think? Stop. It's weird. Oh, it's not weird? Oh, okay. Oh. Oh, you don't? I do. Yeah. Yeah. Like, I'm good at hiding bodies.
Oh, okay.
What? Good night.
All I heard is I'm good at hiding.
so you can
Say, why are you good at
give me
hiding
the
bodies?
final answer. Damien, what are you thinking?
I'm working on it.
Damien's grinding out.
Not done.
I am grinding.
I just did the top one.
Frankie,
Wait, why am I so confused?
I don't know, Josh, you better.
Jackson would be there.
Yeah.
I'm sorry. Should be. That's why I need to be there.
Oh
Oh
my
my
god.
gosh.
I need my calculator.
Me too, please. You win. Wait, now. Oh.
Oh.
Yeah.
Oh, I'm
I'm
out.
very used to it.
Oh.
Okay, I got this.
You do?
What the heck? No, that's.
Oh,
I
I'm
see
close.
what you're saying.
I'm close.
Is that? Oh, that makes sense. Yeah, you do.
Oh, I got it. I got it. Let's go.
Not done yet.
Let's go.
Coming slow.
That is.
That's so accurate.
That's crazy.
You're slow and good at hiding body. How does that work out?
Yeah, you did say that you're good at hiding body.
That's what Dom said.
No, that's what you said.
I said that what all I heard from Dom
That's
is
what
him saying he's good at hiding bodies.
Say, why did you say that?
Stop lying.
Hey, they can
All right, Damien, closing in on it.
Not hiding
I'm
body.
working on it. I don't know what I'm doing.
Wait, what's called? Oh, yeah.
What are you working on, Damien?
I'm trying
Oh,
to
yeah.
figure out. I don't know what I'm doing.
What have you accomplished in the
I'm
program?
trying to figure out
What have you done?
what the answer is.
What have you done?
Specifically, what have you done mathematically?
I've written them out.
That's still not telling me anything.
That's good.
Tell me numbers and order of operations things that you're working on.
I'm dividing.
What by what?
27.
27 by what?
1,900. No, I'm dividing 1,970 by 27.
27 times 27 is 729.
Yeah, that's what I got.
That's why.
729.
3 cubed is 27. And 729 divided by 27 is 27.
Let's go.
Now, pay attention here. If you're grinding all that out, which most of you were, then you missed numerous opportunities for shortcuts here. So I'll show you a few different ways you could view this problem here. The answer is 27 though, but 27 squared by 3 cubed. So here's a few ways you could think about this problem. 27 squared is 27 times 27, right?
Yeah.
And on the bottom, 3 cubed is 3 times 3 times 3, right? What's 3 times 3 times 3? 27. So now I'm basically left with 27 times 27 divided by 27,
Just cancel.
which means they just cancel out, and then the only thing you would have left is there. You could have used, there's one way you could have did it, but just realized, phew, and that's all, they cancel. But on the top here, on the bottom, 3 times 3 times 3, but 27 breaks down to 9 times 3, right? So I could say 9 times 3, and then the other 27, 9 times 3, but you could say 9 breaks down to 3 times 3, right? So I could say 3 times 3 times 3 times 3 times 3 times 3, 6 times is the same thing as 27 squared, right?
Yeah. And then you cancel.
1, 2, 3, 1, 2, 3, still times 1, and then what do you have left on top? 3 times 3 times 3, or 27. All these 3's just cancel each other. That's like using your factor tree. Because you remember these, 27 is 9 times 3, 3 times 3, 27 is 3 times 3 times 3, right? So if you would have used your factorization, and with exponents, you'll have these types of opportunities here to make these cross simplifies all over the place here. You'll see that in tomorrow's lesson. We will do that. We'll be looking to cross simplify different stuff, get rid of stuff all over the place. It's kind of fun. Okay. We are almost done here. Last part. I need to create a couple. So the last part here. Now we're going to apply our two other rules here. Anything to the 0 power is 1, but multiplying things with the same bases, subtract. So we do not need to solve these.
Yes. I was gonna say, because number 30, like, holy crap.
So I'm just going to write a couple out.
I have no. I haven't even used a half a page yet.
Because you're cramming it all together.
No, I'm actually not.
So
Ladies, calm down.
guys, shh. See what you remember. You do not need to solve these, but write your answer in exponential more.
Okay.
The way the directions say to do this is use the laws of exponents to simplify each expression. So I don't need an answer here. I just want 3 to the 4th times 3 to the 8th. Let's see what you can remember. What am I looking for here? Evangeline's not here. Savannah.
Just wait.
Right? Oh, for the first one?
Yep.
So we're gonna want to do like 3 times 3.
We don't need to write it out that way. In exponential form, it's the same thing that we did all, where did I even put it here? Where did I put the notes? Earlier here. Oh, there they are. It's the same thing that we did back here. This situation right here. So instead of 6 to the 3rd power times 6 to the 4th power, now we have 3 to the 4th times 3 to the 8th. But what did I do when I had 6 to the 3rd times 6 to the 4th? What did I do with my exponents?
You added it.
So when I had 6 to the 3rd times 6 to the 4th, what did I do with my exponents?
You added it.
Mm-hmm. What's 3 plus 4?
Like 6, 7.
So then my final answer, 6 to the 3rd times 6 to the 4th was?
So
Like 6, 7.
So now I have 3 to the 4th times 3 to the 8th.
So it's gonna be 3 to the 12.
Right. So all I do is I take my exponents, a 4 and an 8. 3 times to the 4 plus 8. Final answer, 3 to the 12th.
Like 6, 7.
That's what I need. That's it. You don't have to figure it out. 3 to 12. This one, Sierra. 2 to the 5th. 2 to the 0 plus 5 equals 2 to the 5th. Right. Same deal. Apply it's not hard. I mean, it's really not that hard. It's just remembering what to do. When the bases are the same, we're multiplying, add the exponents. Dividing. So do that one and this one. Last two. Last two and then we're done.
Are you gonna have anything for homework? So you call.
Yeah, I'll give you 10 minutes. Yep.
Wait, this could be the longest video.
It probably is.
I told you it was going to be a long, chunky lesson.
This is almost an hour long.
Wait, that will be the longest.
Right.
Not really.
Yeah,
The
long
longest
lesson.
was 54.
Who's missing?
The longest is
Okay.
54.
So last two.
But we still need to this is the longest
28 to the
video.
9th divided by 28 to the 4th. Vandeline. Savannah.
Which one?
28 to the 9th divided by 28 to the 4th.
I'm not ready yet.
That's fine. 4 times is the longest video ever.
And again, we would go back to this page right here when we were.
20,
Yep.
28 to the 5th.
Yes. Right. So when we are dividing, Again, take the top, subtract, or whatever we're dividing, it would be 28 to the 9 minus 4 when we're dividing, and that would be 28 to the 5th power for that one right there. Great.
Oh, there's another one.
Right. Alright, last one. 17 to the 3rd divided by 17 to the 1st. Sierra.
Oh, it's 17 to the second.
Yes. 17 to the 3 minus 1 equals 17 to the 2nd power is what we would be looking for that one. Okay, questions? Take 10 to work, then we'll take a, when we go out, yes. Can you make it for 7 minutes here?
Maybe.
Do whatever you gotta do, Dom. You gotta go to school. Okay, take 10. If you have any questions, look it over there, let me know, I will help.